Hi, we are group 10 and from section 2. So our group's final project is about how can homeowners estimate their housing price. So let's first start with the introduction of our problem. So our problem is finding housing that is within your budget given some key or necessary attributes that you want or need. So we want to be able to estimate how much housing will cost given certain attributes. So why this problem is very important is because we want people to know what kinds of attributes they can expect to have with a listing that is within their budget, or what kind of budget to expect with the kind of attributes that they want or need. So it can help people to distinguish between necessary and nice to have attributes, especially when working with a tight budget. So if we have more time, we could also help someone choose a location to settle in. And for the question, how can we predict the price of a housing listing if we are given the following attributes? So we found the data contains with the following attributes that will influence the housing price in different levels. And we are finding the 10 most important features out of the list. We found out the 10 most important features that are listed in the pictures. So we using decision tree to find out the 10 most important features. And we choose the most basic and main defining features of a unit of housing. And logically, the main weight for price setting would be what people are most likely to be willing to pay for. And next part is the method. So we found out our data set from the OpenML, and our data set contained more than 21,000 housing listings, and each with 20 useful attributes. And for the independent and dependent variables, we set as which attributes to use, which turning parameters to use, and which regression model to use. So these three are the independent variables. And for the dependent variables, we set as which attributes are the top 10 and the accuracy of the model. So for the algorithms we use KNN to find out the highest accuracy.
We're going to talk about what kind of algorithm do we use to build our models, and how do we tune our models, and what kind of numbers do we get. So for tune the model, we use the min-max scaler to normalize the data, and then for feature selection, we use the RFE to eliminate some features that we don't want and choose 10 of the most influential attributes in the deciding housing price. So from this four graphs, you can see among the four regression model model we use, the KNN regression has a better accuracy among all of the other models. So we choose that to build our model and train and test our dataset. And then for feature selection, when we try to find the best number of features we choose, we compare 5, 10, and 15 features, and then as a result, we can see from here that 10 features has a higher accuracy compared to 5 and 15 features. So we choose 10 features that will influence our housing price. And for the visualization part, we first draw a scatter plot, and since there's a lot of data, so the graph is not really straightforward, doesn't tell like the plot of this graph. So then we take the min of each value, and then we draw a line graph out of those data. So from the second graph, you can see the pattern from 0 to 8. You can see the price is gradually going up, although there's some difference, but like you can see the price is gradually going up with the bottom numbers going up. And with the discussion, so the results shows that from this dataset, there are many attributes that will influence the pricing of the house, although some factors influence heavily, some not. For the features selected in the above code, they have significant effect on the pricing of the house. So the algorithm, we compare four of the regression model, and then we choose KNN, and then we get 10 features out of the 20 attributes we have. And for the future direction, so first of all, we're gonna clean up our data even more because we really appreciate this our data set. It's really clean this time. And second, we'll try to tune our data set with more models to boost our accuracy. And then if we have more time, we'll try to find a better graph to represent like how the 10 attributes really have an influence on the price. And lastly, we'll try to get rid of our attribute, and then we'll get rid of some attributes that has almost no effect on the housing price. So to speed up the prediction process and maybe boost the accuracy. And yeah, thank you very much.